All right, number 1 on the follow along says to draw a Bohr model for an atom of oxygen and assume it is a neutral atom. Well, first of all, if we can assume that it is a neutral atom, and we look at the periodic table, we know that oxygen has 8 protons because its atomic number is 8. If it's neutral, it's also going to have 8 electrons. And rounding off the atomic mass, we get 16. And so our neutrons is going to be the mass number minus the atomic number, and that's going to be 8 neutrons. All right, in order for us to draw our Bohr model, in the box we put our number of protons and our number of neutrons because the box represents the nucleus. And then the rings are where we place our electrons. So we've got a total of 8 electrons. I can put 2 electrons in the first energy level, and then the other 6 electrons are going to go 1, 2, 3, 4, 5 on the second ring. So oxygen in this case is going to have 6 valence electrons. It uses 2 energy levels, and that's what the Bohr model of a neutral oxygen atom is going to look like. Number 2 says to draw a Bohr model for an oxygen atom with a -2 charge. All right, well, it's still oxygen, so it's still going to have 8 protons because that's what makes it oxygen. It's going to have 8 neutrons, but it says a -2 charge, meaning that it's going to have a couple of extra electrons. Okay? So if we have 1, 2, 3, 4, 5, 6, 7, 8 protons, then how many electrons do we need in order to have a -2 charge? Well, 8 electrons gives us a net charge of 0, so we would have to have 2 extra electrons to give us a -2 charge. So that's a total of 10 electrons in this situation. So even though we haven't really discussed it yet, the situation is oxygen has gained 2 electrons from somewhere. Okay? Your nucleus is going to look the same because nothing happens to the nucleus in chemical reactions. Chemical reactions are all about what's going on with the electrons. Okay, and in this situation there are 10 electrons. So I put 2 in the first energy level, and then the other 8 will go in the second energy level. Okay? And that second energy level is now full with those extra 2 electrons. Okay? So I know it's got 2 extra electrons because it has a -2 charge, and remember that electrons are negatively charged. All right, number 3 asks, I'm a liquid at room temperature, chemically similar to fluorine, but I use the same number of energy levels as zinc. Who am I? In other words, I'm asking which element am I talking about? All right, it says that I am chemically similar to fluorine, which means that I have the same number of valence electrons as fluorine, so I'm going to be in the same column as fluorine. So this column says fluorine, chlorine, bromine, iodine, astatine, and then this unnamed one. Okay? And then it says I use the same number of energy levels as zinc. Zinc is right here. Zinc is in period 4, meaning that anything in period 4 is going to use 4 energy levels. Okay? So I'm in the same column with fluorine, and I'm in the same row with zinc. And that leaves only one thing, right there, bromine. And bromine actually is one of the few elements that is liquid at room temperature. So who am I? Bromine. Okay, so just reminder, our answer is bromine. The reason why chemically similar to fluorine means that I've got to pick something in the same column as fluorine. If what I'm talking about has the same number of energy levels as zinc, then I need to have something that's in the same period as zinc. So same period as zinc, same column as fluorine, and you wind up with bromine. All right, number 4. I've got just a little portion of the periodic table. I've got nitrogen, oxygen, phosphorus, and sulfur. And the question is, oxygen is chemically similar to, and I want to know which one is oxygen chemically similar to. You guys have learned that elements in the same column of the periodic table have the same number of valence electrons. And because they have the same number of valence electrons, they are chemically similar to those other elements in the same column. So oxygen is in the same column with this one, sulfur. So oxygen is going to be chemically similar to sulfur. Okay, next one says that phosphorus has the same number of VE valence electrons as, all right, we've been learning that if you have the same number of valence electrons, you are in the same vertical column. So oxygen and sulfur are chemically similar because oxygen and sulfur have the same number of valence electrons and they're in the same vertical column. Phosphorus is going to be chemically similar to nitrogen because they're in the same vertical column and they're going to have the same number of valence electrons. So for this little portion, phosphorus has the same number of valence electrons as nitrogen. Why? Because they're in the same column. All right, then the next question says sulfur and who both use 3 energy levels. Okay, so the little piece of the periodic table that we're looking at is right here. Here's nitrogen, here's phosphorus, here's sulfur, and here's oxygen. Okay? Sulfur and what? Both have 3 energy levels. That means that sulfur is going to be in period or row 3, and they're asking who else is in period or row 3, because who else has 3 energy levels? So it's got to be somebody in the same row as sulfur, so that's going to be phosphorus from our choices. All right, next on the back I have a box from the periodic table. The atomic number is 11. The mass number, you're going to round that off. 22.99 is the atomic mass, but it's not the mass number. Take that and round it off, and you should come up with 23 for your mass number. Notice I'm not writing these down because I'm hoping that you are listening and following along. The number of protons, remember, is the same as the atomic number. So if the atomic number was 11, then we have 11 protons. Also, as long as we can assume that the atom is neutral, that is the same as the number of electrons. Remember, ape man. Okay, so the atomic number is 11, number of protons is 11, number of electrons is also 11. How do I find my number of neutrons? Remember that neutrons is mass number minus atomic number. So the mass number is 23 because you rounded it off, minus 11. So that's going to give you 12 neutrons. Okay. All right. How many energy levels are you going to use? Well, you've got 11 electrons. You can put 2 electrons in the first energy level. You can put up to 8 electrons in the second energy level. But 2 and 8 is only 10, so I have to have 1 electron in the third energy level. So how many energy levels are used? There are 3. And then the number of valence electrons is just simply the number of electrons sitting out there in my outermost energy level, which in this case is 1. Which row is this element in? This element is sodium. Well, I'm using 1, 2, 3 energy levels, which means that it's going to be in row or period 3. If I look at the periodic table, sodium is in the very first column all the way on the left, so that's column 1 or column 1A. This you actually have not been taught yet. There is a name for the elements in column 1, and they are the alkali metals. except for hydrogen. Hydrogen's in that column also, but it's a nonmetal. Okay, so fill that in. There should be more on your paper than there is on mine because you are listening and following along. All right, the next one says an atom has 7 protons, 7 neutrons, and a -3 charge. 7 protons. Let's see, element number 1, 2, 3, 4, 5, 6, 7. So element number 7 makes it nitrogen. Okay, so we know that this is a nitrogen atom because it has 7 protons. The atomic number is going to be the same as the number of protons, remember. The mass number is going to be protons plus neutrons. You have 7 protons in this particular atom and 7 neutrons. Okay? In this case, because I gave you a specific atom, you're not going to take the atomic mass and round it off. You're going to use what I gave you, 7 protons and 7 neutrons for a mass of 14. Again, it's nitrogen. Number of valence electrons. Okay, so this one is interesting because it says we've got a -3 charge. I've got 7 protons, and if I have a -3 charge, I've got the 7 electrons that match the protons, but then I've got 3 extra ones. So if I count all of those up, I've got a total of 10 electrons, and I need to know the number of valence electrons. Okay? All right. In the little hexagon that represents the nucleus, you're going to put protons equals 7, neutrons equals 7. You can put 2 electrons in the first energy level. And remember, you have a total of 10 electrons, so there should be a total of 8 electrons on that outermost energy level. So the number of valence electrons is going to be 8. What is the charge of the nucleus? Well, the nucleus contains 7 protons, which are positively charged, so a +7 charge, and the nucleus contains 7 neutrons, which have no charge. So if you're talking about just the charge of the nucleus, that's a +7 and a 0, so the charge of the nucleus is +7. Now, notice I didn't say that that's the charge of the whole entire atom. That's just the charge of the nucleus. The charge of the atom as a whole is a -3, and that's because we had 3 extra electrons. Okay? All right, and I do expect you to make sure that you draw that Bohr model. Even though I didn't draw it for you, I walked you through how to do it. What is the name of the elements in column 7A or column 17? Again, we haven't touched on this, but we are headed that way. Column 17 or column 7A, the one with fluorine, chlorine, bromine, iodine, etc., those are known as the halogens. And number 8, what is the name of the elements in column 8A or column 18? Those are helium, neon, argon, krypton, xenon, radon. Those are known as the noble gases. And they do not form chemical compounds with anybody. They are inert or non-reactive. All right, so that should do it for your walkthrough on the follow along. Please make sure that you've filled in everything.